Now the last topic of today's lecture. Functions. Definition. Let S and T be any sets. Then a function, alpha, maps from S to T, is a rule assigning to each S, an element, alpha of S which is an element of T. Some examples are shown. Notice one thing, the elements of the set does not necessarily be any numbers. It could be anything, such as letters or words and anything. Definition. A function, alpha, is injective if alpha of S1, is equal to alpha of S2, implies S1 is equal to S2, for all si's. Let's define two functions by alpha and beta. See, alpha is not an injective function because alpha of -1 is equal to alpha of 1, but 1 is not equal to -1. So it is not an injective function, but beta is injective because beta of A, is equal to beta of B, always implies, A is equal to B. Another definition. A function alpha is surjective if, for every t, there exists at least one s, such that alpha of s is equal to t. From the previous example, see alpha is not surjective, because there is no a, exist, such that alpha of a, is equal to -1. However, beta is surjective. One more example is shown. And now, a function is bijective if it is injective and surjective. You saw in the previous examples that beta is both injective and surjective, so it is bijective. Let R, S and T be sets, and let alpha maps from R to S, and beta maps from S to T be functions. Then the composition beta alpha, is a function from R to T given by, beta alpha of A, is equal to beta of alpha of A. Some examples are shown. Now, a theorem, let alpha, beta and gamma be three functions maps by the following. Then we'll have the following property. 1. Gamma beta of alpha is equal to gamma of beta, alpha. 2. If alpha and beta are 1 to 1, then so is beta alpha. 3. If alpha and beta are onto, then so is beta, alpha and 4. If alpha and beta are bijective, then so is beta alpha. Another theorem, let alpha be a bijective function. Then there exists a bijective function beta, such that beta alpha of Si, is equal to SF, or all S and, alpha beta of T, is equal to T, for all T. Now an important thing to notice. A permutation of a set S, is a bijective function. From S to S, it sends every member at S to itself, but the order might not be the same.